Imagine you and I are sitting quietly, watching a clock on the wall. The second hand ticks along faithfully, 1, 2, 3. It feels obvious that time is doing the same thing for everything, everywhere. The clock moves, our hearts beat, the day progresses. So naturally, we think time is universal, one great cosmic metronome keeping the same rhythm for the entire universe. That idea is comfortable. It feels right, and it's completely wrong. The mistake comes from confusing what feels obvious with what is actually true. In everyday life, we move slowly compared to the speed of light, so time behaves politely. It doesn't draw attention to itself, but nature has a habit of hiding its most interesting tricks until you push it into extreme situations. Speed is one of those situations. Suppose you take a very good clock, one so precise it can measure billionths of a second, and put it on a fast-moving spacecraft. You keep an identical clock on Earth. When the spacecraft comes back, you might expect both clocks to agree. After all, a second is a second, right? But when scientists actually tried this experiment, the clocks disagreed. The clock that moved ticked more slowly, not by opinion, not by measurement error, by a predictable mathematical amount. This is the first crack in the illusion. Time does not flow independently of motion. The faster something moves through space, the slower it moves through time. That's not a metaphor. It's a rule of the universe. Now here's where it gets interesting. As speed increases, time slows down smoothly. There's no sudden jump, no warning sign. But the effect grows stronger the closer you get to the speed of light. And light is special. Light doesn't just move fast, it moves at the same speed no matter who measures it. Whether you're standing still, running, or flying through space at enormous speed, light still outruns you by exactly the same amount. This creates a problem. If everyone must measure light at the same speed, then space and time must bend themselves to make that happen. The universe solves this problem by adjusting time. Clocks slow down, durations stretch. Events that seem simultaneous to one observer are no longer simultaneous to another. Push this idea all the way to the limit, and you reach something extraordinary. As an object's speed approaches the speed of light, its time slows down more and more. And at the exact speed of light, time stops entirely. Not gradually, completely. That doesn't mean time almost stops for light. It means that, from light's point of view, there is no passage of time at all. The universe allows this because light has no mass. Anything with mass is forbidden from reaching this limit, because stopping time would require infinite energy. So the deep lesson here isn't just about clocks or equations, it's about the structure of reality. Time is not a universal river flowing everywhere at the same pace. It's part of a flexible system, woven together with space, responding to motion. And once you see that, you can never look at a ticking clock the same way again. Let's start with a simple question that sounds innocent but turns out to be dangerous. How fast is light moving right now? You might say, well, it depends. Am I standing still or moving? That would be a perfectly reasonable answer for a baseball or a car. But nature doesn't allow that answer for light. Light refuses to cooperate with common sense. No matter how you chase it, light always runs away from you at the same speed. If you move toward a beam of light, you don't measure it going slower. If you move away from it, you don't measure it going faster. Every observer in every state of motion gets the same number. This is not a philosophical preference. It's an experimental fact. We checked, again and again. Now pause for a moment and appreciate how strange that is. In everyday life, speeds add and subtract. Run after a train, and its speed relative to you changes. But light ignores this rule entirely. It behaves as if the universe has decided this number is sacred. Nothing is allowed to change it. And once you accept that, the universe demands payment. Because if light speed is fixed for everyone, something else has to give, and that something is time. Imagine two observers moving relative to each other, both measuring the same flash of light. For them to agree on its speed, they must disagree about how much time passes and how much distance is covered. There's no way around it. The mathematics doesn't care about our intuition. To keep light speed unchanged, time stretches for one observer and shrinks for another. This isn't some abstract trick hidden in equations. The universe performs it openly. Atomic clocks on fast-moving satellites tick slower than identical clocks on Earth. If we didn't correct for this effect, GPS would fail in minutes. So when your phone tells you where you are, it's quietly confessing that time itself bends to protect light's speed. Here's the key idea: the universe doesn't treat time as a rigid backdrop. Time is negotiable, space is negotiable. What's not negotiable is the speed of light. You can think of it as a cosmic trade. The universe says, I will give you different versions of time, different versions of distance, different ideas of simultaneity, but I will not give you a different speed for light. And remarkably, this deal works everywhere, every time. This also explains why the speed of light feels so fundamental. It's not just the speed of something moving through space. It's the conversion factor between space and time themselves. It tells you how much space you trade for time when you move. So when we say the universe adjusts time, we don't mean it does so out of kindness. It does it out of necessity. If time did not slow down, if distances did not contract, the laws of physics would contradict themselves. That's the strange elegance of it all. Reality isn't built to match human intuition. It's built to be consistent. And consistency, it turns out, requires that time be flexible and light be absolute. Once you see that, the constant speed of light stops being a curiosity and starts being the central rule that shapes the entire universe. Now we're going to talk about something that sounds impossible, so the first thing to do is stop trying to imagine it visually. Our brains are wonderful, but they evolved to throw rocks and avoid predators, not to understand what happens at the speed of light. So if your intuition starts protesting, that's a good sign. You're on the right track. We often ask, what does light experience? That question is already a bit illegal, because light doesn't have a rest frame in the usual sense. You can't sit next to a photon and look at your watch. But physics lets us push the idea mathematically, and when we do, the answer is astonishingly simple. For light, no time passes at all. Think about how time behaves as speed increases. We already know that moving clocks run slow. This isn't a guess, it's measured. The faster you go, the slower your clock ticks compared to one at rest. There's no magic jump, just a smooth, continuous slowdown. So we can ask a very reasonable question. What happens at the limit? As an object approaches the speed of light, its time stretches more and more. A second for you might become a minute, an hour, or a year for someone watching from far away. Push the speed even closer, and the stretching becomes extreme. The mathematics doesn't wobble or break. It gives a clean result. At the speed of light, the time interval collapses to zero. Zero is not very small. Zero means none. So from the point of view allowed by the equations, light is emitted and absorbed in the same instant. A photon leaving the surface of a distant star and striking your eye billions of years later does not experience those billions of years. For the photon, there is no journey. There is only emission and absorption welded together into a single event. This is where people usually object and say, but we see light traveling. It takes time to get here. Of course it does, for us. Time passes for observers who are not moving at the speed of light. The mistake is assuming that everyone must agree on the same timeline. They don't. The universe never promised that. In fact, this explains something deeply strange about causality. Light connects events across the universe, but it doesn't age while doing so. It carries information without experiencing duration. That's not poetry, that's physics being brutally literal. And notice how carefully nature protects this situation. Anything with mass is forbidden from reaching light speed, because reaching that speed would mean stepping outside time altogether. To do that would require infinite energy. The universe doesn't allow loopholes. So when we say time stops for light, we don't mean light presses a pause button. We mean that time, as a concept, no longer applies along light's path. The distance through space remains, but the distance through time vanishes. This forces us to confront an uncomfortable idea. The flow of time is not fundamental. It depends on how you move through the universe. Light doesn't move through time at all. It moves only through space. Once you accept that, something remarkable happens. The universe starts to look less like a movie playing frame by frame, and more like a complete structure where past, present, and future are connected by paths, and light traces the edges where time simply isn't there. Let's now talk about why you can't just keep speeding things up forever and eventually turn them into light. It sounds reasonable at first. Push harder, add more energy, go faster. That's how things usually work. But the universe has drawn a very firm line, and it draws that line using mass. Take any object with mass, a grain of sand, an electron, a spaceship. As you give it energy and make it move faster, something curious happens. It doesn't just gain speed, it becomes harder to accelerate. You push with the same force, and you get less and less additional speed in return. It's as if the object is becoming stubborn. This stubbornness isn't psychological. It's built into the structure of space-time. As the object moves faster, its motion through time slows down, and motion through time is not optional. Every massive object must move through time. That's the price of having mass. Now here's the key connection. The closer an object gets to the speed of light, the slower its time flows. From the outside, its internal processes crawl, clocks slow, particles decay more slowly. Everything that requires time begins to freeze, but it never quite freezes completely. Why not? Because freezing time entirely would require reaching the speed of light, and that requires infinite energy, not a lot of energy, not more energy than we can currently produce. Infinite energy. The mathematics says so without hesitation. This is why mass and light speed are incompatible. Light has no mass, so it doesn't have to move through time. Matter has mass, so it does. That single difference explains the entire barrier. People sometimes say that mass increases as speed increases. That's a useful way of talking, but it can be misleading. What's really happening is that energy is piling into the object in such a way that changing its speed becomes nearly impossible. The universe isn't letting you cheat by turning matter into light through acceleration alone. And notice the elegance of the rule. The speed of light isn't just a fast speed, it's the boundary between two categories of existence. On one side are things that experience time, on the other side are things that don't. Every massive object lives inside time. It ages, it decays, it changes. Light does none of these things. It doesn't age, it doesn't wear out. It simply exists as a connection between events. This is why you can accelerate particles in laboratories to astonishing speeds, 99.9999% of the speed of light, and still never cross the line. You can get arbitrarily close, but you can't arrive. The closer you get, the more energy you need, until the requirement becomes infinite. The universe doesn't budge. So when we say time stops at the speed of light, we're also saying something else. Stopping time is forbidden for anything with mass. Time slowing down is allowed. Time stretching is allowed. Time nearly freezing is allowed. But time stopping entirely belongs only to things without mass. That's not a technical inconvenience. It's a deep organizing principle of reality. Mass ties you to time. Light is free of that tie. And that is why no matter how hard you push, matter can never become light just by going faster. Up to now we've been talking as if time were something that happens to objects, like paint drying or a battery running down. But once you follow the argument far enough, that picture quietly falls apart. Time isn't a process happening inside the universe, it's part of the universe itself, stitched together with space in a way that only reveals itself when you push reality to its limits. In classical thinking, time is a stage. Events march across it in neat order, past, present, future. Everyone agrees on what now means. That idea works beautifully as long as nothing moves very fast and nothing strange happens. But the moment you take light seriously, the stage starts wobbling. When two observers move relative to each other, they don't just disagree about how fast things are moving, they disagree about which events happen at the same time. This is deeply unsettling because simultaneity feels sacred. Surely now must be universal. But the universe doesn't share that opinion. Two flashes of light that occur simultaneously for one observer may occur at different times for another. Neither observer is wrong. Time isn't broken. Our assumption was, the universe never promised a single global present. What this tells us is that time is not flowing independently, it's woven together with space into a single structure. You can't pull one without distorting the other. Motion through space changes how you move through time, just as turning a sheet of fabric pulls on everything connected to it. This leads to a radical shift in how reality is organized. Instead of imagining the universe as something that happens, it's more accurate to imagine it as something that simply is. All events, past, present, and future, exist within this four-dimensional structure. What changes is how different observers slice it up into moments. Light makes this structure visible. Because light experiences no time, it traces paths through space-time that ignore the flow we're so attached to. It connects distant events without aging, without waiting. In a sense, light reveals that the universe is not governed by a ticking clock but by geometry. This is why equations of physics don't care about now. They describe relationships between events, not moments sliding forward. The laws work equally well forward and backward in time. It's our experience, our biology, that gives time its arrow, not the fundamental structure of reality. Once you accept this, the old picture of time as a river carrying us along starts to feel like a convenient illusion. Useful, yes. Necessary for daily life, absolutely. But not fundamental. Reality looks more like a completed book than a story being written line by line. Each observer reads it in a different order, at a different pace, depending on how they move. Light, interestingly enough, doesn't read at all. It connects the pages directly. This doesn't make time unreal. It makes it contextual. Time depends on the path you take through the universe, and that realization, forced on us by the behavior of light, changes time from a background assumption into one of the most dynamic features of reality itself. By now you might feel that all of this is interesting, but abstract, CT, clever ideas about clocks, light, and equations. So let's bring it back to something unavoidably human. What does this do to the way we understand our own existence? Every time you look at the sky, you are seeing the past. That's not poetic exaggeration, it's a factual statement. The light from the sun takes about 8 minutes to reach your eyes. Light from distant stars takes years, centuries, or millions of years, so you might think you're looking at ancient history. And from your point of view, you are. But here's the twist. From light's point of view, none of that time exists. The photon leaving the sun and the photon hitting your retina are not separated by 8 minutes in its experience. There is no waiting, no travel. Emission and absorption are the same event. The entire history in between, the vacuum of space, the spinning earth, your decision to look up belongs to you, not to the light. This forces an uncomfortable realization. The universe does not agree on what long ago means. What feels ancient and distant to us can be immediate and local from another perspective. Time is not a universal label stamped onto events. It's a relationship between them. Now consider what that means for causality. Light is how causes connect to effects across the universe. A star explodes and long afterward we see it. But light itself doesn't age during that connection. It links cause and effect without experiencing duration. The universe allows information to travel without time passing for the messenger. That alone should make us pause. It means that our everyday sense of time flowing forward is not written into the deepest level of reality. It emerges from how we, as massive beings, move through space-time. We are tied to time because we have mass. We decay, metabolize, remember. Light does none of that. So when we ask where we are in time, past, present, future, we are asking a question that only makes sense locally. The universe as a whole doesn't carry a wristwatch. This also reshapes how we think about beginnings and endings. Light from the early universe is still reaching us today. To us, it has traveled for billions of years. To the light, it has traveled for zero time. The birth of the universe and your observation of it are neighbors along light's path. That's a remarkable compression of cosmic history. And it humbles us. We like to think of ourselves as living at a special moment called now, with the past behind us and the future ahead. But physics suggests something subtler. Now is not a property of the universe, it's a property of us. The discovery that time stops for light doesn't trivialize human experience, it deepens it. It tells us that our sense of flow, change, and aging is not the whole story, just one way the universe can be experienced. Light shows us a reality where distance exists without duration, where connections are immediate, and where time is not the master we thought it was. And once you absorb that idea, existence stops looking like a race against the clock and starts looking like a vast interconnected structure, one where we are participants, not spectators, moving through time while light quietly reveals that time itself is negotiable.